Afternoon, everyone. My name is Brad Schmidt. I'm with the state of Colorado, and we'll be presenting a little different this year. We've been talking about what we've been doing to deploy TAC for public safety for a couple of years here at the Offsite. That project is maturing, and we wanted to share not just what we're doing with TAC, but actually get into the weeds a little bit on how we're architecting some of our systems, specifically around user management, and how we integrate external data feeds, which has been a hot topic this afternoon, into TAC. So thanks to the TAC Product Center for having us. I'll be speaking for a little bit, and then I'll be turning it over to the much more capable hands of Bob Gann and Nick Ingalls, who have developed a lot of these systems on behalf of our office. So we all three of us, we work for the Colorado Department of Public Safety. We're in the Fire Division, and the Center of Excellence for Advanced Technology Aerial Firefighting is where we work. It is primarily a research and development office, so we've been doing R&D into TAC since 2016, and very early on identified, it's a great tool. It provides an extreme value proposition to first responders, so we wanted to scale it up and take it from being an R&D project and make it into an actual operational system for public safety. And so 2022 was a very big year for us. That year we received funding from the Colorado legislature to build out COTAC, which is TAC for the state of Colorado. And then that same year, we'd been getting some 1 year at a time cost share agreements from the Federal Forest Service, the USDA Forest Service. That year we received a 5-year agreement with the explicit goal of building out an enterprise scale TAC capability for wildland firefighters nationwide. That is the WOOF-TAC project. I know it's silly, but it's the Wildland Fire Team Awareness Kit. So those are the two projects that we are currently building out. I'll brief them in a little bit of greater detail here in a moment, but just wanted to get up on my soapbox for a little bit and talk about kind of how we have approached those two projects. We are kind of sticking to these principles as we build TAC out. First off, we want to use off-the-shelf GOTS TAC products whenever possible. So we use GOTS TAC server to support all our deployments. Otherwise, we are developing those gap-filling capabilities specifically around user management and data interoperability in-house, and we're retaining the IP rights to that code. We're also focusing really quite tightly in on the basic Blue Forest tracking capability of TAC, and really our flavor on that is we want to make that capability as interoperable as possible. So enable Blue Forest tracking not only within your agency, but with your neighboring agencies, or even across the entire state of Colorado, or across an entire region for wildland fire purposes. We are also focusing in on cursor on target, or COT. We know that TAC can support a whole bunch of different GRG formats and varieties of maps, but what we've really found is that by focusing on taking an external data feed, and prior to serving it to TAC, we translate it into COT. That enables us to have maximum interoperability. And the reason for that is what I'm showing in this pie chart here, is the types of TAC clients that we're seeing out in the field. So this is real world data that's pulled off of our COTAC system. We've enrolled about 2,800 certificates at this point. So 2,800 different times people have connected the TAC apps to our server. And what we're finding is that 58% of the time, our users in Colorado are using iOS and iTAC to operate. 19% Android, 9% Windows, and then sometimes it's unknown. We don't get a fingerprint back from TAC server to know what type of client it is. So this is probably pretty eye-opening, but this is kind of the reality that we live in public safety, especially in the COTAC system. It is a BYOD system. We support over 120 different agencies across the state of Colorado with COTAC, and so this is the type of devices that are being brought to us. So we know that iTAC is a much newer product, and so that's why we're focusing in on cursor on target, because we have the best chance of having interoperability between all the different flavors if we're relying on COT as opposed to a KML, some other type of GRG, or some other external data feed that maybe it works great in ATAC, but it's not going to work for us in iTAC or WinTAC. Some of the other principles that we're trying to adhere to is to avoid the use of plugins, MDMs, additional logins, and other barriers to adoption by first responders. And I know it's a little bit harsh to say that we're avoiding plugins, But the reality is again, we're focusing laser in on that Blue Force tracking mission, and we want to ease the adoption process for our users. As folks become more familiar and become those power users that we all love to see in TAC, we want to facilitate their success with plugins, but we have to recognize that ease of adoption is really the paramount thing for us. If you can imagine, if you knew nothing about TAC, if you're just a firefighter or a cop, and someone told you that you had to install another app on your phone, a lot of our users kind of initially look at that with about the same enthusiasm you would look at if you had to get an app from your electrical utility or your bank loaded onto your phone. They don't know how great TAC is yet, and so we want to make it as easy as possible for them to gain access to it. And we'll share how we're doing that with our authentication strategy and how we get people enrolled on our TAC server to do that. And then finally, our priority is to deploy all of our resources in a highly available cloud environment. So we've selected AWS GovCloud to deploy all of the systems that we're going to brief today to ensure maximum uptime, system availability, as well as scalability. So the two projects that we're going to brief today, COTAC, again, the Colorado Team Awareness Kit, that is available to any first responder at any level of government as long as they're physically located inside the state of Colorado providing public safety services. So unfortunately, all those requests that I get from sheriff's offices and fire departments all across the country that want to join COTAC, I'm sorry, but you have to be within the state of Colorado to join us. We definitely want to see TAC proliferate across the country, but we can only support the state of Colorado with that project. So within Colorado, we have actually delegated the authority to each agency that uses COTAC to manage their own users as well as create their own channels for use in the TAC apps. Where we come in as the state is if we need to create a mutual aid capability between multiple agencies inside a county or between multiple counties or perhaps even the entire state of Colorado, we can create mutual aid channels that are TAC channels to enable that interoperability. And then finally, we're providing content and training to make this system as easy to adopt as possible. But largely, we're allowing local agency administrators to decide how they want to use TAC and when they want to use it. The other project, WOOF-TAC, we're building that on behalf of the USDA Forest Service. It will be for use by all 5 of the national land management agencies, as well as cooperators down into state and local government. It is a much larger project. It's just getting underway at this point. It's in limited beta testing in the Pacific Northwest with some national forests there. But ultimately where we're going to go with that project is deploy it across at least the 2,800 units that are engaged at the federal level in wildland firefighting. So that's every ranger district from the Federal Forest Service, that's every national park, every Bureau of Land Management field office across the entire country. We are also looking to deploy thousands of TAC channels that will be geographically based as well as incident based. When a larger wildland fire occurs, we have to automatically create a new TAC channel so that firefighters within that incident can collaborate without bothering people on other wildfires across the nation. So we're relying significantly more in that system on utilizing APIs. We know when a wildfire breaks out. We know when a wildfire gets big. We're using the APIs from those systems to govern the creation of TAC channels and place the users in appropriate channels when they get a resource order to go to a large type 1 or type 2 fire. So those are the two projects that we're engaged on. At a very high level, the system architecture for both of these projects is what you see on the slide here. Our real world users, they're either using the TAC app and connecting to a GOTS TAC server that we operate, or they are an administrative user that's logging into our website. In the case of COTAC, it's cotac.gov. They create a user account there. They can create multiple accounts for all of the first responders within their agency. That information gets passed to TAC server, and then when you connect your TAC app, you get authenticated and issued a client certificate. We also do federate with other TAC servers, currently with the FBI, and we're going to federate the two systems that I'm talking about today with each other for interoperability purposes. And then the final piece is the ETL server. And ETL is extract, translate, and load, and that is our data interoperability capability, which we have built in-house so that we can bring in vehicle tracking feeds, CAD feeds, serve that from an external source into TAC, and then also take TAC data and bring it out of TAC and display it into an ArcGIS feature service or other GIS environment. So those systems are what we've been operating. CoTAC has been live for about 2 years now. WoofTAC has been live for about 6 months. They are scaling up. We intend to go into the tens of thousands of users for both of these systems in the coming years. But today, we're going to really zero in on the two systems that we build and maintain in-house. First off will be our web application, which Bob Yan will be briefing. And then the second feature that we'll be briefing is our ETL server from Nick Ingalls. So without further ado, I'll turn it over to Bob to discuss our web application.
Thanks, Brad. So my name is Bob Yan. I'm a native of Colorado, was a firefighter for 36 years. I'm also an electrical engineer by trade. So I somehow got pulled into this idea of moving things together. What I'm going to talk about today is how we manage users in CoTAC and WoofTAC to a certain extent, although we'll focus more on CoTAC. One of the challenges for TAC in Colorado, what we recognized when we started looking at it, was we had no robust way of managing users. And as I'm sure you know, if you have to issue certificates manually or shared certificates, there's lots of overhead there. So we needed to create a system where a local agency could manage their users. Colorado is a local control state, so the legal authority for wildfire in a county in Colorado is the sheriff. It's not the state. So we don't want to, nor should we, be managing their people. I don't know who's in a volunteer fire department or a local fire department, police department. I don't know who's there. I don't need to add them. I don't want to add them. So we built a system to do that, and that's what I'm going to talk about right now. We do use channels very heavily, and it sounds like North Carolina's doing the exact same kind of thing. That works really well, and we can segregate that data into those channels in a very nice way so that local agencies can actually control very carefully what data is shown. So a SWAT team can even be set up so that only the SWAT members, not even the other policemen, can see where they are, or they can share that. And this can all be done at the agency administrator level. Okay, so it does present as a web page. So if you go to cotac.gov, you're going to see a web page, but what's behind there is actually a really quite sophisticated application. And the way it works is CoTAC, the application, and when I say CoTAC, what I'm talking about is that web application, is the source of authority. So that's where the users are certified, that's where their passwords and everything is managed, that's where they're enabled, disabled, logged in. We pass that data to an LDAP server. It's open LDAP. We are running secure LDAP. This is all encrypted and everything. And so we write the users and the channels to that LDAP server. And the channel is a group in LDAP, so it's an organizational unit. But we write the structure there. TAC server picks that up, and then the user logs in with TAC either from a device or maybe web TAC or whatever. They provide their username and password, the same one they use for the web page, and they are authenticated and enrolled into TAC. So that's the architecture of it. We'll speak a little bit more detail about some of those in a minute. It is a hierarchical structure, and I kind of gave you that idea a little bit. Brad mentioned it. The agencies inside CoTAC, and this one is actually WoofTAC, are hierarchical. So you can see that WoofTAC is the top, and then below that we have BLM, U.S. Forest Service, BIA, National Park, and Fish and Wildlife. And if you expand those, you see that there's a whole structure under those. So we can set up users and channels to propagate up and down that tree, or to be stuck at a tree. So we can say this channel is only for this agency, or this channel is for everybody in this agency, and below it, just one level or all the way down. So it's a hierarchical structure which allows us to really create these mutual aid channels in a very capable way. We do have a number of different agency types. In CoTAC, the parent-child structure is used for primarily mutual aid. So maybe we'll have a county, and the county will have several agencies in it, police, fire departments, whatever. We'll put mutual aid channels at the county level perhaps, and so all of those agencies can see data on those channels, and they can turn it on and off in their device. Or only certain agencies, and the agency administrator can control that. Or we can have it down at a channel where maybe a local fire department, only they can see their people, so they can control what information they're sharing. And as Brad mentioned, There's a hierarchical structure up. So if we want to do a state mutual aid channel for maybe a big wildfire where we need everybody able to see it, every user in the system has access to those limited mutual aid channels. In WolfTAC, it's the same kind of thing. You saw that structure, but it's all automated. It's all pulled from national data systems because there are 2,800 offices and thousands of firefighters, 11,000 firefighters. We have to manage that automatically. We cannot manage that manually. You just can't hand jam that many people. So it's all automatically run, pulling from federal API systems. As Brad mentioned, one we wanted to do was make this first agency manageable so the local agencies can handle it, and also very easy to join. So here we have, just a schematic of the web page. There's a button. If you go to there in the upper right corner, that says sign up. So if you're a new agency, you're a fire department in the Colorado, and you decide you want to join TAC, you come here and you push that button. And you say, I want to request a new agency account. And at that point, you send an email, we validate the email, and that comes to us as the COTAC administrators, and we make sure that that's a valid request. It's a person that really represents that agency. That's really about the only time we touch it. Once we find out that that person is the right person, that is a person who has authority to do that, we approve it. And at that point, we create the agency account, we create a default channel, the whole structure is built automatically behind the scenes, and they are assigned as the administrator for that agency. Okay? At that point, they can send their responders to the same web page, and the responders say, sign up. Except this case, they say request a new user account. They pick their agency, maybe my fire department. That email goes to the agency administrator, who then approves that person for joining. They know who their people are, so they can say, yep, that's one of my people. I'm going to let them join. And now they are simply in ATAC. They've validated with their password. They can log in with ATAC, ITAC, WIDTAC, whatever, and they're on the system. We also create channels. By default, we create one channel for an agency. It's an all-user channel. But they have the ability to create segregated channels, and I'll talk about that in a little bit. So here is, I should look here. Here is a list of example channels. So I wanted to show how it shows up in the web page. As a user of TAC, I would go up to admin and I'd say, show me my channels. And those same channels show up in TAC. So there's a one-to-one match. What you see in your agency account is what you see on your phone. Channels are actually very powerful. So the first thing is, a channel to us is just a communication path. And we can use it as a TAC channel, which means it's going to show up in TAC. We can also use it as an email channel, which means administrators can send an email to everybody that's on that channel. Or we can use it as SMS. So we could send a text to everybody that's on that channel. So we can use these. These are just communication paths for us, essentially. By far, the majority of them are TAC. But we add these because perhaps maybe something goes down with the system during the middle of an emergency and we need to let everybody know there's a problem with the system. We can send a SMS text message to that same group of people. Each channel is, you can set whether that channel is available to just that agency and the people right below it, or to everybody below it. So in that hierarchy, you can control where that channel visibility is. And then last, there are lots of ways to control who has the channel. So you'll see all users. That means everybody in the agency will get that channel. But we can also say responder types. And if we do that, then we can say only the firefighters, or only the policemen, or only the EMS responders will get this channel. And it automatically will assign those people to that channel. We can also do it manually. You can have it one by one where the administrator comes in and says, this person, and that person. Those three people get this channel and that's it. Or you can do any combination of these. So just because sometimes in pictures worth 1,000 words, here's a short video of how it flows. So I'm here, I'm logged in under Colorado Department of Fire Prevention and Control. I bring up my channel list and I'm gonna go to a channel called TAC in the Cockpit. This is a channel we had for a test thing. And I'm gonna look at the users in there and I'm looking down and I see Bob Gand is not in this channel. I wanna be in this channel. And just to show you how it works, this is the LDAP view and it's a lot of reading, but you're gonna look there, you're gonna see that TAC in the Cockpit channel, it's not there. So I go back to the website, I add myself, it looks up Bob Gann, that's the only Bob in that agency. Whoops. And I say, attach me to that channel. You look down below and you're gonna see that I'm now listed as that channel. If I go to LDAP and I refresh it, it's gonna pop up at the bottom. There's a new channel for Bob Gann. And now if I go to TAC, same thing happens. I can look at the channels. This is a TAC on my Android phone. Look at the channels, you see there is no TAC in the cockpit. Within 60 seconds, the TAC server will let me know that as user Bob Gann, I have new channels. And do I want to join them? I say yes. Now that channel is there and I can turn it on. That's how easy it is to join and to manage the channels in this system. It's very focused on making it easy to do. So that's an overview. It's a very light touch of what we did. There's a ton behind this. Took about 1.5 years to develop this code. A lot of work, but it's very usable. It is implemented. People want to know, how do we do this? We used a system called Laravel, which is an open source development system for PHP. There's a number of key factors there. I talked about this thing called Eloquent Relationship Manager. This is basically a database management system, and we have very complex relationships between all these different aspects, users, channels, agencies. That's a very complex data structure. And you know, if you're an SQL guy or a database guy like me, your head explodes thinking about the queries that are there. So with Eloquent, it's actually abstracted very nicely. So you could have a relationship which ties down to, this is what the user sees. Here's the kinds of users I can have, responders. That is tied to a relationship with what's called a belongs to many. That tells me that a responder could be one of many or more than one. It pulls it into the model. It tells me whether or not that type of user has automatic channels created and things like that. And I'm ready to go. So I didn't have to write a query. Behind that query is like 5 different really deep relationships that would be an SQL query that would drive you crazy. But it's all abstracted, which makes it doable. If we didn't have this capability, we would have never gotten this done. Security-wise, we do pay attention to security. We're running, as Brad said, in AWS GovCloud. We're running on Ubuntu, which is a Linux release, in AWS. Laravel itself has been around for about 15 years and it's built on something called Symphony, and it is regularly scanned for security. We do run security scans on it regularly, looking for any kind of vulnerabilities that come up, and we do get regular updates for that. And then finally, we do an automated test suite. So every time I push a button and deploy, there's a whole suite of tests that runs to make sure what I've got actually returns what we expect it to. We're not quite at 100% coverage, but we're getting close. And basically, it's every button you click in that web page, we are clicking it virtually and seeing if it's actually responding correctly. We do use LDAP in GovCloud. Again, all this is in GovCloud, and the attack server's in the same cluster of GovCloud. So all the data actually stays inside GovCloud. It doesn't transmit around the internet. Everything's encrypted. We do require 2-factor authentication for administrators, but not for responders. And there's a rationale to that. That is because these people are responding to emergency. Having to deal with a 2-factor authentication when they log in is probably not something they want to do. An agency could choose to turn that on for their people, but by default, we don't require it. And we do minimize the amount of personal information we do keep there. As far as our tax server data, it is deleted automatically very regularly. So if an agency wants their history in TAC where they're moving around, they have to request it because it will go away. And if they call us after that short period of time, we're going to say it's not there because it isn't. It's gone. Wolf TAC, I want to talk about the architecture a little bit. It is very similar to CodeTAC. It's the same code base. It is more complex in terms of the architecture. Instead of just having agencies, we have units, geographical units, global area or geographic area coordination centers. We have incidents, we have prescription burns, we have prepositions, and it's all populated automatically. Much bigger system in terms of the user interface. But the whole system is structured for flexibility. It's all metadata driven. So if I want to create a new type of agency, I can do that without writing any code. So as much as possible, we make this thing configurable so that we can move with it rapidly and easily. We do have the ability to brand it, which means that's why we could take the COTAC one and make it WOOFTAC. That's driven by variables in the system. Again, just a matter of changing it. It's not like we're going through the code and changing the name everywhere. It's just driven by the metadata. And so we really do try to limit the code differences to the two streams as much as we can. And that's where I'm done. I'm going to turn it over to Nick, who's going to show you how we integrate data, which is really cool.
Hey folks, my name's Nick. I work Mountain Rescue in Mesa County. On the left side of the screen, back where those blue lines are. Formerly with Mapbox, I was one of their early developers back when we were in an unheated garage, and you kind of straddle a space heater in between typing. So I'm going to show off CloudTac today. CloudTac is both a web-based viewing tool that is cloud native. So we focus on large geospatial imports and being able to view them alongside TAC data, as well as being an extract, transform, load tool for external data sets into TAC. So I wish I could do a live demo, but the internet was such today after lunch that I just have some pictured slides that I'll walk through. Cool. So ETL servers, similar to Node-RED for folks already pulling in data via the ETL process. We pull from just about any external data set that you can think of. We can write a short script to pull it in. The management of the script is managed by CloudTac, and then eventually it lands into COTAC, or data can also be pushed externally from the COTAC server to an external source. At the moment, primarily Esri. So this is just an example of a few of our integrations that some of our partner agencies are using right now. Cool. So the web map on the front, like I said, has like WebTech like functionality. The more interesting stuff on the ETL side is the back end. This is an example of a connection, which is essentially like an ATAC-like connection that's managed on an EC2 in the cloud. So we can see here it's got a name and description, the kind of uninteresting parts. The layers tab on the left is active AWS Lambda-based integrations that are pulling data from those external data sets, whether on a schedule or via webhooks, and then placing them into like data locations on the TAC server. For example, this data location here, the Abbey forecast, that's signifying that it's landing into a data sync instead of straight into a connection. So we can see here the channels that Bob mentioned. Like our actual user groups, machine users and connections are managed by the authentication system, and they're assigned channels that they're allowed to push data into. Once again, straight into the connection as COTS or into a data sync. So here's two data syncs managed in an automated fashion by the UI. So we have trail files, which is essentially a KML base map for Mesa County. And then parcel data, for example, is just a larger vector tile-based data set for dispatch. Right here, I don't have an example of one, but we have outbound syncs. It manages a webhook connection, and then from the server to the TAC server, a TLS connection. We have the ability both to push data in, like I said before, via the layers, or also pull data out of the TAC server and push it to an external source. Right now, we're pushing all of our first responder locations at their behest to an ArcGIS Online map server that can be queried by more traditional geospatial tools. And these syncs are performed live, so as the data comes in via TAC, they're live pushed out to ArcGIS Online. We also have health monitoring of the connection, and then as we kind of move further into the layer process, we'll also show the monitoring that we do of our actual incoming ETLs. Cool. So this is an example of a data sync. The ETL server manages its own data sync, so it lives alongside the ability to manually create a data sync in a TAC client via ATAC or ITAC. You can also create a data sync managed by an ETL connection, and then it will automatically manage the contents within that given data sync. So here's, for example, an automatically updating that trail file that I'd mentioned before. This would be an example of a static file that would appear in the data sync. And then as we move forward, we'll show you the layers. The CAIC Avi forecast would be an example of a dynamic layer, so more of that Node-RED style data flow, where we're going out at a set interval and pulling in new data into the data sync. So this is setting up a new layer. It's entirely UI. There's no command lines that you need to touch. It's as simple as naming it, giving it a description, telling how often you want the data set to run. And then we have a suite of pre-built integrations. So you could say, I want to pull from CalTopo, I want to pull from SARTopo, I want to pull from an ArcGIS Online or an Esri endpoint. And then it will give you a very generic config and build up a UI automatically for you that is going to let you enter the details you needed. So for example, for CalTopo, it's going to ask, hey, what's your share ID? And then it's going to do everything else for you. It's going to set up all the infrastructure on AWS. It's going to set up alarms, monitoring, and you're going to set, how important is this to me? Should I wake Nick up in the middle of the evening if this stops working? So this is all automated and abstracted away. This is a layer that's actually running. This is another. This one's Active 911. For folks in the first responder community, it's a common commercial platform for pulling first responders out of bed onto an incident. In Mesa SAR, we use this one, and this is an example of the monitoring. It's monitoring. This is the logs from CloudWatch on AWS. This is the UI for configuring the actual underlying cloud infrastructure. For the most part, we set defaults based on the task type. But a power user can also go in and say, like, hey, I have an extra special layer with a lot more data than useful and increase stuff like the memory or the timeout. Finally, environment. This is the part that's dynamically generated. So we use, for the tech geeks in here, we use JSON schema for everything. The data is validated with JSON schema. The interfaces are built with JSON schema. Data flowing all throughout the system is validated and the UI generated via those JSON schemas. So when I create a new integration, I specify via JSON schema what I need in order to run that integration. For example, here I need a username and password, and then it will build up a UI within CloudTech that will make sure that it requests that information, validates the user input, and then builds up the AWS infrastructure to run it. We also, like I said, all of our ETLs are generic, so that we don't have any hard coding of variable names. Every Esri map layer has different variables, different columns. So there's also the capability of each ETL layer to self-report the schema dynamically of the data coming through. So this is an example of fields that are coming from this specific integration. And this is useful as we then have a UI for generating COTS, for dynamically generating COTS. And I don't know if we can see it's easier. Oh, there we go. So up here we can dynamically set the call sign. We see this a lot in Esri style endpoints, for example. There's not necessarily a defined display field. So we can manually define a display field that's going to appear on the call sign of the COT. We can manually create the remarks field using a templating engine called Handlebar. And then we can also dynamically generate style information. So we could assign colors, all of the various stylistic properties that COTS expose. And then finally, the really interesting part, we also support an arcade, an Esri arcade-like query language, so we can actually dynamically style data coming in from external ETLs based on properties of the data. So for example, for CAD types, we can style icons different for a law enforcement event versus a fire event via this dynamic data styling. Finally, we also have differential-based updates of mission data. So one of the biggest problems that we had early on was pushing data straight into a connection versus using data sync, is that there's no easy way, especially for stuff like CAD incidents, where there's no clear end date. Like the stale value only gets you so far. We don't know when the event is actually going to end to perform deletes on the user devices. So what we've done is we've built out a diff-based updater that can be used by any ETL that's integrated into the system that will actually compare an external data source with the contents of a mission sync and then perform the deletes and upserts dynamically. This is once again, this is back into the front end, into the actual viewer. You can see here Austin paddled Ruby Canyon. And this is 2 different CalTopo layers being automatically pulled into TAC and diffed separately. So we'll pull over. So here example is the data sync plugin actually supports a layer hierarchy, much in the way that CalTopo does. Unfortunately, we're the first client to implement it. So we use that layer structure on the back end to differentiate to separate out the diffs, so we can diff against a specific layer. So the top layer there, SAR-topo test, we're pulling in from a specific SAR-topo layer and diffing within that layer. And then I also added a second SAR-topo layer, building polygons, that we diff in separately. So we can pull in multiple sources into a single data sync and then diff those sources separately. We can also we support kind of all of the various authentication strategies for data syncs. We can invite based on channel membership, or invite based on the UI. So here's an example of a member list in a data sync, much like what you'd see in ATAC. Mission timeline. Folks have probably seen this in ATAC if they've used data sync. This is just showing content over time. So right here you can see the important part is that all this content is being managed automatically by that ETL server, regardless of what ETL source it's coming from. Questions? Sure.
I don't mean to put you guys on the spot. One, this is really great. You guys are doing a great job. Have you had anybody ask you for the user management piece and say, copy paste and we'll add in X state? What does that look like for sharing your work?
Yeah, that would be a policy question, I think, for Brad, and then a technical question for Bob. So I'll let them take the floor.
Yep, that is the big question, isn't it? We are already kind of going down this path, right? This code was first built for the COTAC project and then repurposed for WoofTAC. So we are working on the technical capabilities to make that possible. It really becomes a policy and a workload question for us. And so I'll go ahead and share that we have submitted a proposal to join the configuration steering board for TAC. And one of our main contributions for that would be to take ownership of the ITAC product and sustain it. We would also contribute all of the code that you've seen today to the broader community. Now that contribution would probably look a little different than what you might be used to seeing with some of the other TAC products. We look at this as it's pretty complicated enterprise scale software. So what we're considering at this point, and again, this is just considerations, is that we would be looking to license this at no cost. You probably still would require to work with a contractor of some sort to configure not only the capabilities that we briefed, but all the underlying AWS infrastructure, the email servers, the SMS servers that make all this possible. We would be looking to connect you with folks that can help you with that, but we would be looking to license this at no cost. So that's the direction we're hoping to go. If we're not successful with that application, we'll be looking at other strategies, but certainly our goal is to get this capability out there and make it available more broadly. Nick's code, the ETL server, it is available on GitHub. He has fully open sourced it. It is very specific to AWS. He hasn't mentioned all of the different capabilities that he pulls in to operate this, but we're using a lot of ECS, and to execute the ETL functions, we're using AWS Lambda, so it's running in a serverless configuration. So it's not something that we can just throw onto a Docker or put it on a Raspberry Pi, but it is something that we want to provide out to the capability of other programs that want it. So I'm sorry we don't have a firmer answer, but that is the direction that we want to go.
And our GitHub repo, I should have put a QR code on here just if folks do want to see our open source contributions, is dfpc-coe. If folks want to look that up. The vast majority of our work, we're doing our best to open source or are in the process of open sourcing, like Brett said.
And as far as the user management system, it was architected from the get-go with the idea of being able to rinse and repeat. It's just not a simple, it's not like I can hand you a piece of code and say run this on your local server. It's a little more complicated than that. But we're absolutely committed to try to figure out how we can make this happen, because it's a critical need that we want to help supply.
Any other questions?
Oh, we're supposed to look at the.
There's nothing.
Oh, oops.
Hey, another one.
Sorry, I got one more. Part of what the struggle we have in North Carolina and maybe other agencies or someone bringing in kind of a boutique piece of data and saying, hey, I want to see this attack?
So the question is, integrations are a lot of work. Where do we draw the line for the work that we do to integrate?
Yeah, so again, a policy question. Some of the criteria are, first and foremost, the integration has to be coming from an existing either COTAC member agency or from one of our federal partners on the WolfTac side. If a vendor wants to, they think they've got a great system that they want to integrate with us, we're happy to talk to them, but we can't allocate developer time until we've got a customer on the other end for that integration. Within that, we are so far in early days with this project, so we haven't had to prioritize too much, but certainly looking at the extensibility of something, something like Active 911 or Rapid SOS, where we know there are a lot of users of that system out there, that would probably take, precedence over a boutique CAD system that only one or two agencies uses. But we are providing that capability free of charge to COTAC member agencies. We're just doing that on a best effort basis. So we can't make your CAD vendor create an API, but if they do have an API, that's where we have hired Nick and funded him to take that and make that work to serve it into TAC.
And then from the developer side, we all of the AWS Lambdas or the ETLs are Dockerized, running on Lambda, and we provide a Docker environment, specifically in Node.js, but any Docker environment would work, that provides pre-built libraries for interacting and pulling data both out of an external source and then formatting it into Cloud TAC. One of the advantages, like I said, we're focused on being cloud native, so using kind of modern geospatial formats. So one of the first things that we do for the ETL side of things is we use GeoJSON throughout the process. So everything has a one-to-one relation between the actual COT XML and GeoJSON. So a lot of times we get free integrations because modern web APIs already speak GeoJSON, and we can just pipe the GeoJSON directly into CloudTAC, and it will handle all of the abstraction from the GeoJSON back into the COT XML that TAC speaks natively, or TAC Proto.
Yes, in the back. Why? So the question is, why doesn't DHS take the lead on this? Yeah, I mean, that's not a question I can directly answer. I mean, what I would say is, I think, especially on the COTAC side, we have a really great role to play as a state level agency to build and maintain this system, because states are where that vast majority of public safety incidents, they don't escalate to the federal level. They're either handled exclusively at a local level or they're within a county or a region. In Colorado, we're very unique and fortunate to have a statewide voice radio system for public safety. So if I'm a fire chief or a police chief, rather than building my own radio tower and building my own little voice radio network, I can hop on the state digital radio system for public safety, and then I can use that radio system for my daily operations just within my own agency. And then I literally turn the knob on the radio, and now I can mutual aid with agencies across the state on voice radio when a large public safety incident occurs. And so we saw that we could extend that concept to TAC by building COTAC and doing it at the state level, so that we have both that daily operations with TAC as well as that interoperability between agencies when people need to see each other's locations. WolfTac is a unique beast. Wildland fire is one of the few disciplines in public safety where I would say we truly have national interoperability. We pull fire engines from Maine to California and back to Maine again every year. And so it makes sense for WolfTac to be built out as a national project. For other types of public safety disciplines, it's still relatively rare and cumbersome for responders to cross state lines. You see it with hurricanes and with large unique situations, but it's still relatively rare. We would always welcome more federal help on this type of work, but we're pretty happy with the systems we're building at the scales that we're doing it at. Any other questions? All right, well, thank you.